Hello. Another little project. I'm going to show you how I did this. FreeCAD version, in this case 017 13494, relatively new version. So let's begin. We're going to work in the part design workbench, and it's going to be a little knob, sort of you find on lawn mowers or other things, where you have a M8 nut inserted in a knurl style knob. Surely one could download this thing from Thingiverse, but I want to do this as a teaching project, so let's just start to create it. What we're going to do is, first we're going to create a new body. File, new. In the new file we create a new body container, and we call that with F2 knob. It's a good habit to name your stuff as good as possible. So first we're going to create good. So the first thing we're going to create is a circle. We create it from the center point of our origin. We just give it a random diameter, and first step is we define its radius. The radius in this case will be 30 millimeters, because the knob's diameter then finally should be 60 millimeters. Then we have a circle that responds to a center part, which we're going to see later, and this circle will have a diameter of 20 millimeters, so 10 millimeters radius. Then we want to have some three ingoing circles later on, which should tangent a circle virtually that is a little bit bigger than this circle. So we create a circle number 3 and give this circle a little bit more radius to have a little bit more material around the nut later on. And let's take 12 millimeters, so it gives us a bit more for the 3D print. We distribute our measures a little bit just to be clearer, and this is about all we need for our master sketch, which gives us our measurements that we're gonna need later on. So we close that sketch, save the sketch, mower knob sorter. So as I had to restart, that's it, good, and OB. So we call that sketch master. Then the next step is that we create a main body. The main body is where we then subtract all our other elements from. So we just create a new sketch. Same plane. And again we start with a circle. Give that circle a random diameter. When you create circles, don't try to create them so they lie on a different circle that exists somewhere, because then it will try to make the circle tangent to the other circle, which for concentric circles is not going to work. So we better do this by choosing a random diameter first, and then using constraints, getting it to the same diameter. So in this case, we want to fetch our master sketch outer diameter. We click this circle, click that circle, and we give it the same size with the equality constraint. Good. So that's the first thing that we have. And for the first part of the sketch, that's all we're gonna create. We close it, and then what we're gonna do is we're gonna pad it to the desired height, which in this case is 25 millimeters. So we use the pad and 25 millimeter. So we want to see it completely on screen. There we go. Now there's several possibilities how we can carry on. A classic possibility would be we choose the upper plane of the knob and start a sketch on that. That will work for a part where we probably never want to change anything, and which is relatively simple. The better way is to always create datum planes which correspond to the origin planes of our body. So what are we going to do? We switch that pad off. We take circles from our master sketch which lies on that plane and which is never going to change its plane. So we can say create a datum plane on. Now we select that, and now as it is concentric to the circle, we have the possibility to move it up 25 millimeters. So fit drawing, okay. It's a good habit to give datum planes, datum geometry names. Knob upper face. Good. So that's what we need in the moment. Next step is that we choose that plane and mouse didn't work. Now it's done it. And create a sketch on that plane just to show you what's going to happen. I will create another circle at the center, give it a random small diameter. I close it, and then I create a pocket through all, and we can now see the pocket goes from above towards the base and through it. So back to sketch 001. What we can see is we still see this datum plane, and we switch it off because it will just not be what we need. Good. So in this case, well, I have forgotten to define a diameter for the threaded rod that's going through it. So let's go back, finish editing, model, master, create another circle, give that circle a diameter of 3 millimeters. Close. Back to sketch 2. And something seems not so well. Good. Again, finish editing. And again, go back to master sketch and see the error. That was the problem. I thought I centered it when I started drawing it, but many times this doesn't work. And then, unless you find yourself being very confident with your mouse and very precise, you better choose random positions and afterwards constrain it. That will make it easier to find errors later on. Good. So we need external geometry, and again we make both equal. We close it, and we now have a 6 millimeter diameter hole in the center. So let's now start with the main shape of our knob. Let's save what we have. Let's select the upper face again. You don't need to see it. At least you have to select it here before you start the next sketch. So what we're going to do is we will need 3 circles. These 3 circles should have equal diameters. We'll make them equal. I don't give them measured diameters in a moment. I want to do this visually and then fix a value. So in the moment we can't see our master sketch logically because our pocket is switched on, and we define this circle, which we're going to fetch with external geometry, and we wanted to have our 3 circles as tangents to here. So tangent to here, tangent, and again tangent. So still have 5 degrees of freedom. That tangent didn't work. Trouble with my mouse somehow. So we can move them, and next step is we want to have them distributed in a manner so they create a knob that goes out here and later on all the way back. So what will we do? We will, as we see it roughly is that diameter, I will just simply choose that diameter and fix one of the circle's center point to it. So now we can still move them around, but all will be fixed to the leading circle. So the next step is we need to evenly distribute them. I'm going to do this by using lines from each of the centers. Just move them again to be sure, yeah, they are fixed. And now the simple trick is make them equal. So we can rotate around, but we can't change the positions anymore in the distribution. What we can do is we fix that one to horizontal, and now the sketch is completely constrained. These three lines, at least they are construction lines. Gotta switch them to construction line mode. After we created the three circles, one would normally think it makes sense to create the whole structure of the three, or one of the three wings that looks in a shape like this. But it turned out that when I wanted to create the geometry for it, I got stuck at one problem that is always there, not only in FreeCAD, that appears in other programs also. If you deal with circles, with tangents, with points that have to be on circles, and shapes that need to be used for all this feature building, they have to be 100% closed. And it turned out that even working a quite long time on it, I didn't make it. So I decided to do it an easier way, which is much more straight ahead. So what we do is we just finalize the sketch at that point, having it fully constrained with the three circles. We close it and we simply do a pocket through all, and there we have this shape. That's all we need at that point. We are now going to create the proper shape for those wings. So the next step is to create a new sketch again on the upper face of our knob, and we need some external geometry. We need this shape, we need this shape, we need that shape. You may wonder why there's a point here. That's because in one of the previous steps I had once cut the circle and then brought it back into action, which is two arcs instead of a circle, but that doesn't matter much in the moment. So the next geometry is a little bit tricky to achieve. What I'm doing is I create two lines. I just put them here. Then I will create another circle. Just put it here. Make this circle help geometry. Then next step is I create two lines. One here, one there. Also make them construction geometry. Now I want to fix these points on the circumference of the circle. Also I want to fix them on the circumference of these circles, and then I let them both lines be parallel. I let them be, I don't need equal length, I let these two lines be equal length. So now this will fix our lines to have an equal distance, and if we now fix these two lines to equal distance also, all we still have is we need to find the proper point on the crossing here, and that can be achieved by one single tangent constraint. So now that is what we have on one of those lines, and we want to cut away some stuff here, so we need to put additional lines here. Here, see if they can still be moved. They can, and we make them equal length. So now they are fixed, and let's see what that creates. Voila, we can now cut this through all, and we can now create a polar pattern from it. 3 occurrences on 360 degrees. All we need, we're done, and we can save. So this already looks quite nice to what it's finally got to be. In the next step we will do a bit more easy work. We switch our polar pattern off. We can switch the master sketch off also, and we create a new sketch. On our XY plane, switch the master sketch on. We need these two circles. That's all we need. We create one large circle, one small circle. Again, don't try to put them on each other while you create them. This will fail. Just afterwards make them equal. So this is all we need for this sketch. Close it. Switch our polar pattern on again. So cutaway reversed, and 5mm is just fine. It's just that there is a face that presses on where the screw applies its force. So before we do some final touches, we need a pocket for our M8 screw. Again, we start at our upper face, creating a new sketch, and this time we choose a regular polygon, which is going to be a hexagon. We start it at the center, put it in, and to have the most possible distance between the flanks and the nut, we fix it to horizontal here, and now all we need is the proper diameter, and we get this diameter by creating a length distance between two opposite outer points of 15 millimeters. That will create the proper shape. We close it and we make a pocket with 10 millimeters of depth. So that is all we need in that case. By principle, the shape is more or less ready. There's just a few things we should finally do. One thing is, if we make that knob completely rigid, even in a 3D print with infill, it might not make a lot of sense. We could cut out a little bit of material here to make it lighter, and we do this by creating a sketch on this plane. We just create a simple rectangular shape that fits, so we still have quite some distance of wall, and then let's see what length that brings. It's 11, so let's take 10 millimeters, and let's check the height. Let's also take 10 millimeters. That will cut out quite some material, and we need to make it fixed in position somehow. So let's make it symmetrical. For some reasons it doesn't want. Then we try again, and yada. So it still could be moved here, so let's fix the distance to the center to 15. close, and we cut it out 15 millimeters. That will still make it rigid, but take away close to a quarter of material. So, looking well, but we still have to create the second and the third of that pattern, and we do it the same way as we did with our wing shape, and that creates 3 pockets. So what else can we do? What else should we do? First, as usual, when you're satisfied, save your work. So let us now choose these 3, use the Control key to choose 3 of the edges, and let us make a fillet so it's smooth in the hands. Looks pretty nice. And we do the same for this shape. When you're doing fillets, be sure to create them in the proper sequence. Sometimes if you're doing fillets in the wrong sequence, it won't work. It will create impossible geometry. Do this. So we want to add more references. Add reference. That one. Pretty nice. So that looks fine. Switch on our master, switch off our master, and let's look at in a shaded view. Well, as I have the original knob in front of me, that looks pretty nice and looks pretty the same as it was before. The last final step in this design is we want to create an STL file that will allow us for a 3D print. So how do we do that? We need the mesh design workbench. As you see, I have already selected my fillet, and I say create mesh from shape. This brings up a dialog. There are 3 different ways of creating meshes. I'm always using standard. I leave it at the 0.10 millimeters and an angular deviation of 30 degrees. Nothing else. Just say OK. Switch off the fillet. Look at my mesh. Just to be sure, we do a wireframe, and we see it doesn't have too much or a large amount of triangles that it creates, but be sure it looks pretty perfect finally. So then you gotta export this mesh to somewhere for the final touch with your chosen slicer. Thanks for watching. Look out for the next videos.